Welcome. In this explainer, we're going to pull back the curtain on something called hyperparameter tuning. I know, it sounds a little complex, but it's one of the most important skills for building truly high-performing AI. We're going to take this from being some kind of mysterious concept and turn it into a practical tool you can actually understand.
Okay, let's just dive right in. And the best way to start is by tackling a really common misconception about how AI models work. It's time to pop the hood and see what's really going on inside.
A lot of people, especially when they're first starting out, kind of picture AI models as these mysterious magic boxes. You just put your data in one side and poof, an answer magically pops out the other. But the reality is, well, it's way more interesting, and more importantly, it's way more controllable than that.
Yeah, a much better way to think about a model is to see it as a high-performance engine. And just like any engine, right, to get the absolute most power and efficiency out of it, you've got to know which knobs to turn and which dials to adjust. These aren't magic, they're precision instruments.
And those knobs we're talking about, they have a name. They're called hyperparameters. Basically, these are the settings that a data scientist, or you, chooses to control the entire learning process. Think of them as the blueprint you create before the model ever sees a single piece of data.
All right, to really get this, there's one critical distinction you absolutely need to understand. Getting this right is fundamental to building great models, and it's all about the difference between the recipe and the cake.
So this table lays it all out. It clearly separates what we, the practitioners, control, the hyperparameters, from what the model actually learns on its own from the data, the model parameters. And just look at the key difference in timing. We set the hyperparameters before training even begins. The model, on the other hand, finds its own parameters during training. One is our choice, the other is the result.
And this is where that analogy just works perfectly. Think about it like you're baking. The hyperparameters are your recipe. You choose the oven temperature, the baking time, the ingredients you're going to use. The model parameters, well, that's the final cake itself. How it rises, its texture, its taste. All of that emerges from the recipe you designed. You control the recipe, not the cake directly.
So now that we know what these things are, let's see why adjusting them, a process we call tuning, isn't just some technical chore. It's actually a deeply strategic move that separates the good models from the truly great ones.
So why even bother? Why spend all this time turning these knobs? I mean, why is this process, hyperparameter tuning, so critical for getting world-class results? Why not just use the default settings and call it a day?
Well, there are three huge benefits. First off, it directly boosts performance, making your model more accurate and precise. Second, it helps the model generalize. This is so important. It's about finding that sweet spot, so it doesn't just memorize old data, but it can actually perform well on new, unseen data. And finally, it makes your model way more stable and robust, so you can actually trust it out in the real world.
All right, enough with the theory. Let's make this really concrete. We're going to look at the actual knobs on a super popular and powerful model called the random forest. This will show you exactly what we're talking about.
The best way to wrap your head around this model is to think of it not as one single decision maker, but as a whole committee of experts. Each expert is just a simple decision tree, and the final decision gets made by a vote. It's like the wisdom of the crowd. A collective decision is almost always more accurate and stable than any single opinion.
So the behavior of this expert committee is guided by its operating rules, which are, you guessed it, its hyperparameters. The three key knobs here are N estimators, which is literally the size of your committee. Then you have max depth, which controls how complex each expert's reasoning can be. And finally, min samples split, which sets the minimum amount of evidence an expert needs before they can form an opinion.
So here's the crucial point. Each of these knobs is a trade-off. A bigger committee probably gives you a better decision, but it takes more time. Deeper reasoning can find really subtle patterns, but it also risks overanalyzing and getting way too focused on past details. And setting a high evidence threshold stops hasty conclusions, but you might miss some weaker signals. Tuning is all about finding the right balance for your specific problem.
Okay, now for some practical wisdom, a real pro tip. Knowing how to tune is important, but knowing when to tune, that can save you a massive amount of time and effort on your own projects. One of the fantastic things about the random forest model is that it's known for being way less sensitive to tuning than other more complex models. It's just incredibly robust, and often it gives you a great result right out of the box, just using its default settings.
This unique robustness makes it the perfect tool for quickly setting a strong performance benchmark.
You can build a random forest model early on in a project to see what's possible and get a really reliable feel for how well a machine learning approach might work for your problem.
And here is the strategic payoff. By getting a good result fast with a model like Random Forest, you can focus your limited and valuable energy on other critical tasks like cleaning your data or engineering better features. And honestly, that stuff often has a much bigger impact on the final outcome than just endless tuning.
So, to quickly sum it all up, just remember these key things. Hyperparameters are your controls, the recipe you set before you start training. The whole process of tuning those controls is the key to unlocking better performance and reliability. And finally, every model has its own unique set of knobs to learn, just like those committee rules for our random forest.
And that leaves us with one final thought to chew on. While the science of tuning can pretty much always squeeze out a tiny bit more performance from a model, the real art is in the wisdom of knowing when to stop. When is good enough, truly good enough for your project, so you can move on and deliver value? That's the question every great practitioner has to answer.